In this video, I'm going to show you how to convert between log form and exponential form. Log form is counterintuitive and doesn't really make any sense to us, while exponents are completely intuitive because we understand that they are just repetitious multiplication. Let's take a look at our definition of what a log is. So we have log base b of a equals c, and we're able to convert that into what's called exponential form. So we start in what's called logarithmic form, which we almost never want. And then we're converting it to what's called exponential form, which we almost always do want because it makes sense to us. So we have log base b of a equals c, converts over to exponential form where the base b is raised to the power c equals a. And I do like to draw in these arrows here. So all you have to do is b to the c power equals a. It's kind of a nice little cycle like that. The other thing I like to point out is that the base, that's still called a base for logarithms. This is also called a base for exponents. So the base stays the base. The other two numbers just flip-flop spots. So maybe that's easier to remember. That's how I remember it. So hopefully that would help you. Two more things that I just want to go over before we continue on to some examples. And that's this property right here that states that if I have a log that has no base, notice that there is absolutely no number right here. If there's no base, the default base is 10. It's almost like the people who made this made the metric system. So clearly no American made this up. But we can see that the base is 10. That seems nice. And one more thing that I'd like to point out to you is that if we have something that starts with what looks like a 1n, that's actually an ln, and let me just highlight what I'm talking about really quick. So I'm talking about this right here. That's an L and an N, and that stands for natural log. And it's ln log natural, because obviously this was done in some other language other than English, where they put the adjective after the noun. And all that means is that it has a log base of e. And e is kind of like pi in that it's a constant number value, but that it's also irrational. And we think that these irrational numbers like e and pi are super cool. They're not that cool. There's an infinite number of them. The square root of 3 is another one. The square root of 2 is another one. People seem to really like pi, but e is the same kind of thing. I think it's around 2.8. It doesn't ever matter because like we did with pi in geometry class, and we're going to do it in trigonometry later on, we're going to keep it in terms of e. So all you need to know is that if we have a natural log or an ln right here, you're just going to rewrite it as log base e. That's all. All right, let's take a look at some example problems now. All right, so our first example is where I put the variable into the logarithm. So we're going to look at 3 examples because there are 3 places for variables, a, b, and c. And we're going to take a look at each one of those so that you guys can solve all of those problems. All right, so if we take a look at this problem here, we're left confused because, well, we don't really know what logarithms are. So the key to logarithms, I'm going to say it a million times, is converting it into exponential form. So again, the base stays the base. It gets raised to that power, and then it equals that number right there. So our conversion takes this type of form. And we could be done there, but 2 to the 3rd power, that's 8. We should know that by now. We should simplify it fully, and then we're done. It's that easy. All of these problems are that easy. All we're going to do is convert them into exponential form and, well, hope that everything makes sense. And it will. Let's take a look at the next example. All right, so in this example, I have made the base the variable that we're going to be solving for. So the b is now an x. So we have log base x of 16 equals 2. Now we're going to learn log properties later on, but you don't need to be able to apply the log properties quite yet. All we need to do for this problem is rewrite it in exponential form. So base stays the base raised to this power equals that value right there. So we get x to the 2nd power equals 16. We could square root both sides, but these are pretty intuitive now that we get them into exponential form. I'm not going to make anything too crazy. What squared is 16? We could obviously square root both sides to get our answer, and we get x equals 4. Because 4 squared is 16. Can't have negative bases in case you're wondering. All right, last we have our variable is going to be in place of our c. And I chose this example because it ties in the second point that I made right here, that if the log does not have a base, it defaults to 10. So let's take a look back over at our problem. This has no base. So what we're going to do to make things a little bit easier is we're going to rewrite it with a base. That's what I always recommend you do. Now it becomes super easy. Base raised to the equals power equals that number right there. So we get 10 to the x equals 1,000. Well, anything 10 raised to any power just tells me the number of zeros that it has here. I see 1, 2, 3 zeros, so x would equal 3. Hopefully this helps.